Hello and welcome to week 4, where we're going to talk about some of the internal processes that we see that affect the marine geology in different areas. And in particular, what we are going to be looking at in video 1 is what is the theory of plate tectonics. And then in video number 2, we'll look at the evidence that exists to support this theory. And then in video 4, we will go into the different types of plate boundaries and what's happening at each one. And then video 4, we'll talk about how plate tectonics are related to major features we see on the seafloor and on coastlines as well. So, first question, what is the theory of plate tectonics? Well, one of the ideas behind this theory is that the Earth is built up of different layers. We've got the solid inner core, liquid outer core, the mantle, the oceanosphere, and then the crust on the very surface, as you can see in this diagram from the USGS. Basically, that top chunk, the lithosphere, the crust, is a brittle surface, and it actually moves and floats on top of a slow-moving, semi-fluid mantle below. So it's kind of this plasticky stuff. And depending on how thick the crust is, the thicker it is, the heavier it is, the lower it's going to sink into the mantle. And then also different types of crusts have different densities. So continental crust, where you see the continents above the ocean surface, have a lower density. And then the oceanic crust is made of denser minerals, denser rock, so it floats lower in the oceanosphere, creates lower lying areas on the Earth's surface where we have oceans that fill in that low lying area. So the crust, this brittle layer, is actually broken up into different pieces. Like you can see here, some of the major and minor tectonic plates that the crust is broken into. And you can see the North American plate, the Pacific plate, South American, Eurasian, African, Antarctic, are all some of the, and Australian, are some of the major plates that we see on the Earth. And then some of the smaller ones are things like the Juan de Fuca in our neck of the woods, the Cocos, the Nazca, the Caribbean, the Indian, Arabian, so on and so forth. Those are all smaller plates that exist as well. And if we take a look here at the North American plate, this kind of brownish color, we can see the continent of North America, United States, Canada, Alaska, and Greenland. And what you see is we have these two different shades. The stuff that's above sea level, that's the continental crust, the lower density, and it's connected directly to that oceanic crust, that's the kind of darker shade in the overall brown color. And that's the same for the other plates as well. South American plate, you have the lighter shade of purple for the continental crust, and then the darker shade of purple for the oceanic. Same idea for all of these locations. So we have these different plates. They're actually moving in relation to one another. And here's a map. You can see the different plates. They're not labeled, but we can see the Pacific plate, which is all oceanic crust, the North American plate. The yellow lines represent plate boundaries, and then the red arrows indicate plate motion, the direction that the plate is moving in, and the size, it corresponds to the speed. So the bigger the arrow, the faster it's moving, the smaller the arrow, the slower it's moving. So these are vectors. You guys are going to have a chance to play around with Google Earth and this USGS plate tectonics file that you're going to download, and I'll kind of give you a preview of that. So here I have downloaded and opened this file in Google Earth. You can see USGS has provided us with this file, and it's showing you 4 different types of plate boundaries. Red is indicating divergent, blue is indicating transform, yellow indicates convergent, and then the white is undefined or unknown. So if we kind of zoom in here on what's happening in our neck of the woods, we see that once we get a little bit closer, we can see the name of the plate, the Juan de Fuca, that you can see in here. The North American plate isn't labeled, but it's a huge area. The Pacific plate over on the other side, and then the arrows telling you the direction that these plates are moving in. And here you can see divergent, boundary, Cascadia subduction zone indicated by that yellow line. So we can go to other areas as well. So if I zoom back out, we can look at what's happening in California. Or let's take a look at what's happening in Africa, the Red Sea. Here we've got a divergent boundary in the middle of the Red Sea. Those two plates are moving away from one another. And let's kind of go back over here to California. And we can see in more detail what's happening here at the San Andreas Fault, which is pretty neat. We've got those arrows showing you the direction of motion in this case. So we can see we've got different plates moving in different directions and interacting with one another. We can see where we have plates, especially in the Ring of Fire, along the Aleutian Islands over in Japan, two plates colliding with one another. What we can tell from that, we can actually see earthquakes and volcanoes that actually get scattered right along those boundaries. So when those plates interact with each other, when they collide, we get convergent plate boundaries. When they diverge or move away from each other, divergent boundaries. And when they slide past each other, like at the San Andreas Fault, we have transform plate boundaries. This is kind of overview of plate tectonics. So we've got the theory of plate tectonics, the Earth's crust, brittle, broken up into different pieces. They're floating on that asthenosphere. They're colliding, pulling apart from one another to produce these different plate boundaries. So in the next video, we'll come back and we'll discuss the evidence that exists to support the theory, and who Harry Hess and Alfred Wegener are and what they contributed to this theory.